Welcome back. Today, we're going to expand on your derivation skills even further using the chain rule. Now, what we're going to do is we're going to find the derivative of a function using the chain rule, using also the general power rule. You get to choose which one you like better. We're also going to simplify the derivative of a function using simple algebra and find the derivative of some trigonometric functions using chain rules as well. Now, when we're doing this stuff with the chain rule, we also will be implementing the use of basic derivatives as well as the product and quotient rule in conjunction with the chain rule. So we got a lot of stuff going on here. This is a long lesson, but by the end, you should be an expert. So, number one, let me explain to you what the chain rule actually is. Here's a set of equations, and they're exactly the same. Okay, now, here's the deal. Without the chain rule, with the chain rule. So these look the same, right? But this is what you would do without the chain rule. You could solve all these. I know the answer to this is 2x, cosine x, 3. Is that 1 plus, I think it's cosecant x. And then you would use whatever the quotient rule is or simplify there, right? So you could solve all these now. But what if I did these and changed it? If this, instead of being y equals x squared plus 1, was y equals the square root of x squared plus 1. Can't solve it right now. By the end of today you will, but right now you don't have those skills. What if this was y equals sine 6x? Ooh, I don't know what to do there. Oh, I do. You don't. What if this was 3x plus 2 to the 5th power? Or if this was x plus 10x squared? Or if this right here, the whole thing was cubed? Now, what do you notice is the difference when you use the chain rule? Anyone? You could yell it out. That's the point. You're at home by yourselves. Yell it out loud. Just shut your door so no one hears you and they think you're crazy. So, right here, I'm square rooting it. I'm raising it to the half power. I'm changing the inside of the trig function. I'm raising something to a power, raising something to a power, raising something to a power. So it's pretty much when you have a function inside another function. Think back to chapter 1. FOG. Remember FOG? Function in a function? This is why we did that. Now, here's actually how a chain rule works. If y equals f of u is differentiable on u and u equals g of x, a differentiable function of x, then y equals f of g of x, FOG, all right, is differentiable in the function of x, and the following is true. The derivative of f of g of x is f prime g of x times g prime x. A lot of words, right? Let me break it down. The derivative of a function is f prime u times u prime. So when you find the derivative of a function inside a function, it's the derivative of the outside function times the derivative of the inside function. That's it. Now, y equals f of g of x is the same as y equals f of u. They're just changing g of x into u. U is just changed because it's like a substitution method type thing. Now, the outside functions are your f's. So that means the g of x or the u would be our inside functions. Still like, what is he talking about? You wait. So, before I even get into the chain rule, we have to go decompose a function. We've done this a while ago, but we've done it. So y equals f of g of x. So you need to know what the inside function is and the outside. So what do you think the inside is? Your u or your g of x or your f of u? The inside is your actual g of x. Ooh, mix these colors up. We got to change those colors. All right, your outside function is your f of u. All right, the f should be blue, the g of x should be red. That's weird. That doesn't matter. All right, so what is my inside function here? X plus 1. Now, if x plus 1 was my inside function and I change this to a u, my outside function in terms of u would be 1 over u. Or u to the negative 1. See that? So we take the inside function, whatever it is, and we're just going to replace it with the u. So let's look here. What is my inside function? 2x. So if this 2x becomes the inside function and we substitute in for u, our outside function is sine u. Right? What about this one? Inside function. All that stuff. 3x squared minus x plus 1. So our outside function would be the square root of that, square root of u. Square root of u is also u to the 1/2. Number 4 is a little tricky. You may say, why does he have tan red and the 2 blue? Well, tan squared x is the same as what? And I tried to make you guys remember this over and over. It's the same as tan x, the whole quantity squared, right? So my inside function is tan x, and my outside function is u squared, right? Better? But let's move on. So, there's the right colors. Blue thing. I gotta go fix that on my real lesson. All right, so do 5 to 10. See, pause it. You're on pause? Let's go look at it. Inside function, 5x minus 8. Outside function, u to the 4th power. Inside function here, x plus 1. Now, if x plus 1 is my inside function, my outside function is 1 over square root of u. What does that equal? Well, square root of u is u to the 1/2, and since it's the denominator, it's u to the negative 1/2. 7. X cubed minus 7 is my inside. Outside is the square root of u, or u to the, we just said it, 1/2. What about 8? Well, inside function is whatever is inside the trig function. So it's pi x squared. So my outside function is 3 tan u. And this is allowed because the 3 is just a constant. It's not part of the, not altering the function. Ow. What about 9? Think back to number 4. Cosecant cubed x is the same as cosecant x, the whole thing cubed. So cosecant x is my inside, and my outside is u to the 3rd. All right, once you get this down, this is one of the harder parts of the chain rule. This one, 5x over 2, and sine. Okay. Now, that you know how to decompose, let's see how to use the chain rule. Number 1, find dy dx for y equals x squared plus 2 plus 1 cubed. I tried to make this steps and I put it next to the actual stuff I would write on the board to make it easier to see. So step 1 is to find u and to find f of u. U is the inside, f of u is the outside. So u is x squared plus 1. F of u is u to the 3rd. Any questions? So just what we did in the last couple problems, that's step 1. Step 2, what do you think it is? It's to derive u and f prime u. So the derivative of u in terms of x is 2x plus 0, because we're just using our power rule. Now the derivative of u cubed, now we're going to derive it in terms of u. So just think of this as an x cubed. 3u squared. Okay? Not too terrible yet, right? All right? Similar to product rule, quotient rule, but not the same. Plug u and u prime, plug u prime and f prime u into the equation f prime u times u prime. So y equals f prime u times u prime. F prime u is 3u squared, u prime is 2x. All right? 3 times 2 is 6. So you get 6x u squared. Now, you don't want double variables. Double variables are, they're not bad, but they're not useful. So what we have to do is do step 4. What do you think step 4 is? You're going to plug u back into the equation. Where do we get u from? X squared plus 1. U is given to us. So we're going to take that, plug it back in. And step 5, simplify. Now, you can leave it like this. This is perfectly okay. If you want, you could FOIL this, x to the 4th plus x squared plus 1. That's where you get that from. And then distribute the 6 into there. And you get 6x to the 5th plus 12x cubed plus 6x. This right here, though, perfectly acceptable. All right? Not too terrible, right? too terrible, but we're going to do a couple more. Now, keep this in mind. I'm going to show you both methods, and then you're going to just see which one you like better. Now there's the general power rule. General power rule states if y equals ux to the n, where u is differentiable function and x and n are rational, then the derivative of ux to the n equals n ux to the n minus 1 du dx. Okay? I know you don't like it either. So it's just pretty much n u to the n minus 1 times u prime. So you're pretty much doing the same thing as the power rule here. The only difference is you're taking the derivative of u prime as well. Now, this method is okay when the problems are simpler. All right, got tongue-tied. But when they get more difficult, there's more things you have to do to it, and there's more chance of you guys making a mistake. So that's why I don't prefer it, but I'm going to show you to do it anyway. Usually, in a class of like 20, 25 students, there's like 1 or 2 in the class that like to do it this way. No problem with you guys doing it this way. But most of the methods I'm going to show, most of the answers in this one, are going to be the other way. All right, so find the derivative of f of x equals 3x minus 2x squared, all cubed. So in this method, you find u and n. What's my u? The inside. So that's the same. But instead of finding f of u, my n is 3. All right? Step 2. What do you think step 2 is? Find u prime and n minus 1. So it's a little different because we're using the power rule. This becomes 3 minus 4x. 3 minus 1 is 2. Now you're going to plug both of these into the equation. N u to the n minus 1 u prime. So n is 2. U is 3x minus 2x squared times u prime, which is negative 4x plus 3. Simplify. So the only way really to simplify this is take the 3 and distribute it to those two. So you get negative 12x plus 9 times 3x plus 2x squared. That's your answer. All right? The biggest difference here is you're pretty much just plugging everything in at the same time as opposed to different times. Like I said before, not a huge fan of this method, but hey, maybe you are. Ready to pick your favorite? What do they say? Pick your poison? So now what we're going to do is we're going to find the derivatives of a couple problems using both methods. And then you guys are going to pick which method suits you the best. All right? So, method 1. The regular method. U. What's the inside there? 4x minus 1. All right? F of u. U to the third power. U prime, derivative of 4x minus 1 is 4. Derivative of u to the third is 3u squared. All right? Still pretty easy. F prime u times u prime. 3u squared times 4 is 12u squared. And the last step is plug u back in. 12 times 4x minus 1 squared. So that wasn't too terrible, was it? No. Let's check out method number 2. U. It's the same u. 4x minus 1. N. What power are we raising this to? The third power. Oh, sorry. Derivative of that is 4. Raising it to the third power. 3 minus 1 is 2. Plug all the stuff into here. N, which is 2. U, 4x minus 1. N minus 1 is 2 times 4. 3 times 4 is 12 times 4x minus 1. Notice answers are identically. Oh, let me get ducked down here. Answers are the same. Oh, that was an E. Which method is better? Whichever way you get the right answer with. All right. Go 14 both ways. This is your homework. Should have done that. Got it? All right, let's look. U is the inside of whatever you're raising to a power. So 6 minus 2x. F of u is 2u to the third. Negative 2x, 6u squared. Negative 2x times 6u squared is negative 12x u squared. And then you're going to plug back in your u. Negative 12, 6 minus x squared, squared. Pointer drop. See how quick that is? This problem right here. Luckily, I have 2 stools. All right, u, same u, 6 minus x squared. N, u prime, negative 2x. N is 3, and minus 1 is 2. Take all this, plug it in here. 2, 6 minus x squared, squared, times negative 2x. Now, here comes the problem. Where did that green 2 come out of? Came out of nowhere, right? It actually didn't. Because there's a 2 right here, you're just deriving this piece right here. So whatever the constant is in front of the function you're raising to a power, you're only actually deriving this stuff, besides the 2, it's just this piece. So you have to remember to multiply it by the 2 in the end. All right, because you have to multiply it back by the constant. Because remember, the basic rules of finding derivatives is a constant times a function is equal to that constant times the derivative of the function. You're just finding the derivative of this function, so you have to multiply that. That's why I don't like this method, because I personally always forget to multiply the constant in the end. Otherwise, you would get negative 6x, but in this case, 2 times 3 times negative 2 is your negative 12x, 6 minus x squared, quantity squared. All right, if you're good with that, go for it. Me, though, I don't like it. But let's try some more questions. Do now problem. And then we'll go back to do some more of those other ones. Use either method. I'm going to go over the regular method, though. So u and f of u. This is just solving using the regular chain method. Your u is 3x minus 2x squared. F of u is u to the third. So this should have been done on Canvas. 2. Find u prime and f prime u. U prime, 3 minus 4x, or negative 4x plus 3. Doesn't matter. I always put the x's first. That's why it's changed. This one, 3u squared. Step 3, plug it into the equation. 3u squared times negative 4x plus 3. Distribute the 3. Negative 12x plus 9 u squared. Step 4, plug in your u. What's our u? 3x minus 2x squared, and that's quantity squared. And you can simplify it if you want. It's simplified enough for me, though, so I'm just going to leave it. So you get negative 12x plus 9 times 3x minus 2 squared. You can't FOIL this in here because it's being raised to a power. Got it? Awesome. All right. We're going to do both methods for problems 15 through 18. The reason that do now was speckled in between what we did and what we didn't do is because that's typically where class ends, okay? That's why you see some do nows and homeworks pop in there. These lessons, in case you guys haven't remembered, is like a bunch of lessons in one. This one's probably like 4 or 5 lessons. All right, so anyway, regular method, u is your inside, 4 minus 9x. F of u is u to the 4th, but it's 3u to the 4th. All right, u prime, negative 9x. F of u, 4 times 3 is 12u cubed. Negative 9 times 12 is negative 108, u cubed. Plug your u back in. Negative 108 times 4 minus 9x to the 3rd power. See, not too terrible, right? That's terrible yet. U, same u, 4 minus 9x. U prime, negative 9. Same. These parts are always the same. N, 4 minus 1 is 3. Plug it all in there. 4 times 4 minus 9x cubed times negative 9, don't forget, times 3. 4 times 3 times negative 9 is negative 108. 4 minus 9x cubed. All right. Next one. Hot potato. U inside, 9t squared. U to the 2/3. 9, 2/3 u to the negative 1/3. 2/3 u to the negative 1/3 times 9. 2 times 9 is 18, divided by 3 is 6, u to the negative 1/3. 6, 9t plus 2 to the negative 1/3. Or you could say 6 divided by the cubed root of 9t plus 2. Both acceptable answers. Right here. U and u prime the same. 9t plus 2 and 9. N, 2/3, and minus 1 is negative 1/3. All right. 2/3, there's nothing in front. So this is an easy method to use. 9t plus 2 to the negative 1/3 times 9. 2/3 of 9, we said, was 18 divided by 3, which is 6, times 9t plus 2 to the negative 1/3. All right. 15, 16, let's do like this. And after this, I'm going to be done with the power rule. But you can still use it. U is the inside, 5 minus t. F of u. Square root u or u to the 1/2. U prime, negative 1. 1/2 u to the negative 1/2. 1/2 u to the negative 1/2 times negative 1 just makes it a negative 1/2 u to the negative 1/2. Plug your u back in. Negative 1/2, 5 minus t to the negative 1/2. Or negative 1 over 2 square root 5 minus t. U and u prime the same. 5 minus t and negative 1. N, 1/2. Negative 1/2. Plug it in. 1/2, 5 minus t to the negative 1/2 minus 1. Negative 1/2, 5 minus t to the negative 1/2. See? You get good at these, you can fly through them. This one. Inside the square root. 9 minus 4x. U to the 1/2. Negative 4, 1/2 u to the negative 1/2. 1/2 u to the negative 1/2 times negative 4. Half of negative 4 is negative 2, u to the negative 1/2. Negative 2, 9 minus 4x to the negative 1/2. All right. And lastly, u and u prime are the same. 9 minus 4x, negative 4. N, still 1/2, and minus 1 is still negative 1/2. Plug it in, 1/2. 9 minus 4x to the negative 1/2 times negative 4. There's nothing out in front, no coefficient to multiply anything by, so you don't need to. 1/2 of negative 4 is negative 2. 9 minus 4x to the negative 1/2. There you go. Both methods, both give you the same answer. You choose. See? Freedom of choice. All right. Move on to problem number 19. What are we? Sorry, just need a drink of water. All right. Find all the points on the graph. This one we didn't do in class. This is like a bonus question just for the video. Find all the points on the graph. F of x equals the cubed root of x squared minus 2 minus 1 squared, for which f prime x equals 0 and those which f prime x does not exist. So, first thing you do is you rewrite the equation. How can I rewrite this? We know that radical, right, x to the a, radical b, x to the a is x to the a over b. So this would be x squared minus 1, 2/3. Now that we rewrote it, we can solve it. Solve it normally, and then we'll deal with these two pieces. These two pieces are just added bonuses. So u is the inside, which is what? X squared minus 1. F of u is u to the 2/3. U is 2x. F prime u is 2/3 u to the negative 1/3. If you use the power rule, that's fine. We're going to end up with the same answer. 2x times 2/3. 2 times 2 is 4/3 x u to the negative 1/2. 4/3 x, x minus 1 to the negative 1/3. All right? So that right there is the actual derivative. Now the two things added on here, find all the points for which f prime x equals 0 and f prime x doesn't exist. This is something that we're going to have to do in chapter 4 when you're doing graphing, because this will help you find out where your critical numbers are, where your critical points are, stuff like that. So I'll just give you a quick little preview. All right, don't worry about it too much for this test, but down the road you're going to have to do this. So when you have this question right here, now what you want to do is you want to find out when it's equal to 0 and undefined. Now when something is equal to 0, right, what has to happen? What has to be 0? The numerator has to be 0. So we don't care about this stuff right here because this is negative 1/3. That's down in your denominator, right? So whenever 4/3 x equals 0, right? 0 times this stuff, or 0 divided by this, it's 0. So 4/3 x equals 0. 0 divided by 4/3 is 0, right? I'll get to that. So x is 0. Now x squared plus 1 minus 1 to the negative 1/3. As you can see, as I was trying to explain before, I didn't realize I put this in the thing. When this equals 0, it means 1 over x squared minus 1 to the 1/3 of the cubed root of this, 1 over that equals 0. Because you do not have 0 in the numerator, this will never equal 0. There's no way to make it equal to 0. So we don't really care. I was just going to gloss over that and skip it, but I guess I threw in the lesson. So, f of x, f prime x equals 0 at 0. When doesn't it exist? Well, when doesn't something exist? When there's a negative under a square root. Now, since this is a cubed root, you can have negatives under it. Or when your denominator equals 0. So this is the actual equation here. I just rewrote it. I put this down here. So we don't care about the numerator. We just care about the denominator. So when the denominator equals 0, what happens? Our equation ceases to exist. So when does this equal 0? What do we do? Divide both sides by 3. You get cubed root of x squared minus 1 equals 0. You're going to cube both sides. So this to the third power is just x squared minus 1. 0 to the third power is still 0. You're going to add 1. And what's the square root of 1? I want you to say it out loud because you might be wrong. Or, you should add two answers, it's plus or minus 1. All right, so this problem right here, the derivative is undefined at plus or minus 1 and at 0. Okay, so that means that on your graph, at plus or minus 1 and at 0, your graph could be changing from like something being a function that's increasing to decreasing, or decreasing to increasing. You would have to put it through another series of tests to see. But like I said, it's a little preview of fun things to come. And just think, that's only like a quarter of the problem that we'll be doing. All right, anyway, let's get back on track. Differentiate g of t equals negative 7 over 2t minus 3 squared. First step here is to rewrite the equation. Rewrite it. I want you to do this in chunks like me, not just copy. All right, so negative 7, we know that 1 over x to the a is x to the negative a, so we can put this whole thing to the negative 2. All right, yes you can, that's the easy way to do it. Now you can use the chain rule. What's my inside? 2t minus 3 is my inside. What am I raising it to? F of u is negative 7 times u now to the negative 2. Derivative of this, since we're using t's here, just everything's in terms of t, 2. Derivative of this, negative 2 times 7 is 14, u to the negative 3, because negative 2 minus 1 is negative 3. Multiply these two together, 14 u to the third times 2. 2 times 14 is 28 u to the negative 3, and then just simply plug back in my negative, my u. So it's 28 2t to the negative 3 minus 3 to the negative 3. If you want to be fancy, you can rewrite it and put it as 28 divided by 2t minus 3, all cubed. Either way, good answer. All right. Problem 21, 22. These are your homeworks. All right, so first one. U. It's u. Inside, right? Because this is all raised to the 1/3 power. So my u is the inside, 6x squared plus 1 to the 1/3 power. 12x, 1/3 u to the negative 2/3. Multiply them together. 1/3 of 12. 12 divided by 3 is 4x u to the negative 2/3. Take my u, which is 6x plus 1, and plug it back in. 4x times 6x squared plus 1 to the negative 2/3. That's it. I feel like I'm moving fast here. It's so much easier teaching without having to have you guys stop and do problems, stop and do problems, stop and do problems. Fly through these lessons. You guys can't pause whenever you need to, and you'll be set. U to the inside, x squared minus 2x plus 1, all to the 1/2. So the inside, x squared minus 2x plus 1, f prime u, u to the 1/2. 2x minus 2 plus 0, 1/2 u to the negative 1/2. You should be able to do this one in your head by now. Just go from one to the other. The derivative of u to the 1/2 is 1/2 u to the negative 1/2. Know it, because we do it so much. Multiply the two by each other. Now, when you do the 1/2, you're going to have to distribute it to the 2x and to the negative 2. So this becomes x minus 1 times u to the negative 1/2. X minus 1 times x squared minus 2x plus 1, all to the negative 1 half. Or x minus 1 over the square root of x squared minus 2x plus 1. All right. Ooh, you had a lot of homework. Problem 23. Yes, you can use the quotient rule if you want, but let's just use the chain rule for these. U is the denominator because it's x minus 2 to the negative 1 half. So u is x minus 2, f of u is u to the negative 1. Sorry, not negative 1 half, negative 1. Derivative of this is 1. Derivative of this is negative 1 u to the negative 2. But watch how easy this is. 1 times negative u to the negative 2 is negative u to the negative 2. Negative x minus 2 to the negative 2. Or negative 1 over x minus 2 squared. Not too hard, right? Here, that's my u to the negative 1. 2t plus 3, same thing, negative u to the negative 2. So in this case, though, negative u to the negative 2 times this, you just make this a negative t minus 3. You can distribute the negative, or you can just leave the negative out front, u to the negative 2. My u is all that stuff. So negative 2t plus 3, or negative 2t minus 3, it's up to you to decide which one, times t squared plus 3t minus 1, all to the negative 2. Or you can do negative 2t plus 3 divided by this stuff squared. Up to you however you want to proceed. Multiple ways to write the same answer, all are correct. All right? Do nows, the two do nows. All right, you should be done with them. They should be in your canvas. 2 times 9 minus x squared to the 1/4 power. If this was a 6, this would be 1/6 power, and so on. What's your u? Inside 9 minus x squared. F of u is 2 u to the 1/4. All right. Negative 2x, and this would be 1/4 of 2 is 1/2. 1/4 minus 1 is negative 3/4. Multiply them together. Oh, this comes out nice. Half of negative 2x is negative x, u to the negative 3/4. Negative x, 9 minus x squared to the negative 3/4. Right. Here, negative 5, x plus 3 to the negative 3. X plus 3 is my u. Negative 5 u to the negative 3 is my f of u. Derivative of this is 1. Derivative of this is negative 3 times negative 5 is 15u to the negative 3 minus 1 is negative 4. 1 times anything is itself, so it's just 15u to the negative 4. Or 15 times x plus 3 to the negative 4. 15 divided by x plus 3 to the 4. All right, let's go to 4, 25, 26. We didn't even get to the hard ones yet, though. We're still in level 1, not level 2. All right, so we're not even halfway through our lesson. What we do here? Watch this. You want to see magic? Distribute the 2. 1 squared is 1. T minus 3 squared is t minus 3 squared. So now this is just t minus 3 to the negative 2. Can you do that? Of course. We know exponential rules. Back in chapter 1. U is t minus 3. F of u is u to the negative 2. U prime is 1. F prime u is negative 2. U to the negative 3. All right. Still okay? Awesome. 1 times anything is itself, so it's negative 2u to the negative 3. Negative 2, t minus 3 to the negative 3rd power. All right. Problem 26. U, 2 minus 9x. Negative 3, 2 minus 9x to the 1/2. All right. U is 2 minus 9x. F of u is what? What is it? Negative 3 u to the 1/2. See, you were just copying. All right, u prime is negative 9. This is negative 3 over 2 u to the negative 1/2. All right, you can put the negative here, 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 it doesn't matter. Negative 3/2 times negative 9 is, negative and negative is a positive. 9 times 3 is 27 over 2, u to the negative 1/2. 27 over 2, or 13.5, whatever you prefer. 2 minus 9x to the negative 1/2. Right? Uh-oh. Finding, next level. Can you read that? Finding the derivative of a product with the chain rule. Now comes the fun. Ready? You guys got lucky. Over the years, I was able to box this off and color code this and set this up so it looks a lot better. When I first started, it looked like a bunch of chicken scratch on a board. Now, modern technology, hopefully you guys can follow. All right? Hopefully like colors. If you don't like colors, it's not going to help you. All right, so first thing, what rule do you think we have to use here? You're correct. It is the product rule. F times g prime plus g times f prime. What is my f? I told you we weren't going to lose this. First function, x squared. All right, this is x squared times 1 minus x squared all to the 1/2, right? So my f is x squared. My g is 1 minus, oops, sorry. My f is x squared. My f prime is 2x, right? My g is 1 minus x squared to the 1/2. How do I find my g prime, though? Chain rule. Boom. So, you have your product set up. On top of your product, you're going to do a little chain. So, what is my u? 1 minus x squared. What is my u prime? Oh, sorry, what's my f of u? U to the 1/2. What's my u prime? Negative 2x. What is my f prime u? 1/2 u to the negative 1/2. All right? F prime u times u. 1/2 u to the negative 1/2 times 2x. Half of negative 2 is negative x u to the negative 1/2. Negative x, 1 minus x squared to the negative 1/2. Now this is the derivative of this. So this is my g prime. All right? So I use the chain rule right here to find g prime. I know what f prime, g. To find g prime, though, I have to use my chain rule. Now that I have these four, I don't care about this stuff anymore. That's why I kind of highlighted it. You just use it, and then you lose it. So f g prime, g f prime. So x squared times negative x, 1 minus x squared to the negative 1/2, plus 1 minus x squared to the 1/2 times 2x. X squared times negative x is the only thing you can really combine here. And then there's 2x you're just going to drag forward. So this becomes negative x cubed, 1 minus x squared to the negative 1/2, plus 2x, 1 minus x squared to the positive 1/2. All right? This would be part of a fraction here if you wanted to be. The square root and so on, but this is perfectly fine. All right? Not too terrible, right? Ready to try another one? All right. Let's see if you can do another one. This is going to be homework. Use the last one as a guide. Not fun starting to stare at the blank screen, right? So the first thing we look at, we go, oh, product rule. We got 3x times x minus 2 to the 4th. F is 3x squared. F prime is 6x. G is x minus 2 to the 4th. Because this is raised to the 4th power, we have to use the chain rule. Don't you love doing multiple math and problems? In a class, we would typically do about 4 or 5 problems. That's it. Just so you guys know about the time it should be taking you at home to do this. All right, one of these problems when you start takes about between 5 and 10 minutes, depending on how good you are. And then eventually we'll try to get it down to between 2 and 5 minutes. Forever. All right, so we got this. Our u is the inside, x minus 2. Our f of u is u to the 4th power. Derivative of this is 1. Derivative of this is 4u to the 3rd power. 1 times 4u to the 3rd power is just 4u to the 3rd power. I take my u and I plug it back in. 4 times x minus 2 cubed, which is my g prime. F g prime, 3x squared times 4x minus 2 cubed, plus x minus 2 to the 4th times 6x. 3x squared times 4 is 12x squared, and then the 6x just gets dragged forward. That's it. See? Getting easier. Got the hang of it yet? Should we switch things up on you yet? I'll give you one more. Go. All right, let's see how you did. F is x. F prime is 1. G is 3 minus x to the 9th power. Cubed. Cubed means chain rule. Anytime you see something raised to a power, a function to a power, you can use a chain. U is the inside, 3x minus 9. U to the 3rd power. 3u squared. 3 times 3u squared is 9u squared. 9 times 3x minus 9 squared, which is my g prime. X times 9, 3x minus 9 squared, plus 3x minus 9 cubed times 1. 9 times x is the only thing you can really multiply here. This times 9 is itself. So you get 9x times 3x minus 9 squared plus 3x minus 9 cubed. Question, can you flip these two? Of course you can. Okay, because there's a plus, it doesn't matter which one you put first. I typically just go in the order that they give me. All right. We got another one. See this homework back to back? We only got a couple done in class. Product rule. You got your 1/2 x squared. You got your 16 minus x squared to the 1/2. What's my f? 1/2 x squared. 1/2 times 2x is just x. G is 16 minus x squared to the 1/2. Because you're raising it to the 1/2, you have to use the chain rule. U inside 16 minus x squared. Derivative of that is f of u to the 1/2. Negative 2x, 1/2 u to the negative 1/2. Follow me still? Negative 2 times this stuff. Half of negative 2x is just negative x, u to the negative 1/2. Negative x, 16 minus x squared to the negative 1/2, which is my g prime. 1/2 x squared times negative x, 16 minus x squared to the negative 1/2, plus 16 minus x squared to the positive 1/2 times x. All right. X squared times negative x is negative 1/2 x cubed. This x is all by itself, so it just gets triangle. Negative 1/2 x cubed, 16 minus x squared to the negative 1/2, plus x times 16 minus x squared to the positive 1/2. Isn't this good when you guys can do these problems? Ready to do the last one? Last one like this. See, now that you're getting good at this, I'm going to change it up on you. Sorry. It happens. All right, not yet though. First step, what are you going to use here? Once again, you're going to use the product rule. X times 1 minus x squared to the 1/2. F is x. F prime is 1. 1 minus x squared to the 1/2. Up, raising it to the 1/2. Boom, we're going to use our chain rule. 1 minus x squared, u to the 1/2, negative 2x, 1/2 u to the negative 1/2. Negative 2x times 1/2, half of negative 2x is negative x, u to the negative 1/2. Kind of similar to a problem we already did. Negative x, 1 minus x squared to the negative 1/2, which is my g. All right? X times negative x, 1 minus x squared to the negative 1/2. So these become negative x squared. 1 minus x squared to the negative 1/2. 1 minus x squared to the positive 1/2. All right? Step, now that you guys are good at that, let's go to something else. Find the derivative of a quotient with the chain rule. Quotient means what? Divide. This is not really more difficult, but it is a little more annoying. Quotient. We got x over x squared plus 4 to the 1/3. Can you just make this x squared plus 4 to the negative 1/3 and use the product rule? Yeah, you can technically if you want. Anyway, we're going to use the quotient rule because that's what I said I want you to use. What's your f? F is the numerator, which is x. F prime is 1. G is the denominator, x squared plus 4 to the 1/3 power. Because I'm raising this to the 1/3 power, means I have to use my favorite rule, which is the chain rule. U, x squared plus 4. F of u u to the 1/3 power. All right? U prime, 2x. F prime u, 1/3 u to the negative 2/3. Okay? Because 1/3 minus 3/3 is negative 2/3. 2x times 1/3, u to the negative 2/3. 1/3 of 2x is just 2/3 x. Okay? U to the negative 2/3. Take your u, x squared plus 4, and plug it back in. 2/3 x squared plus 4 to the negative 2/3, which is my g prime. Up until this point, this is the same exact things that you did to solve the last set of problems. Okay? Product of quotient rule, everything's the same until you get to this step right here where you have to plug it into the equation. This is the only place it differs. Okay? So now plugging it into this equation, which is different, make sure you're doing a quotient equation. Too many times I see people doing problems, and what they end up doing is they end up not solving the problems. They just solve using whatever equation they want. With division, you have to use this equation. 1 times x squared plus 4 to the 1/3 power minus 2/3 x to the 2/3 plus 4 to the negative 2/3 times x. Now, as far as reducing this problem, we don't have to go crazy, but a problem like this is easy. 1 times anything is just itself. So this stays x squared plus 4 to the 1/3. Now, you have a 2/3 x here and you have an x over here. I can multiply these by each other, okay? Negative 2/3 x times x is negative 2/3 x squared. Also, 1/3 to the second power. It's just 1/3 times 2 is 2/3. So I can reduce that as well, okay? Because when you raise a power to a power, you multiply the two numbers. So I end up with x squared plus 4 to the 1/3. That gives me negative 2/3 x squared. This stays the same. X squared plus 4 to the negative 2/3. And then it's just x plus 4 to the 2/3 power. Now you may ask, well, wait a second. I see x to the 4 squared plus 4 is here. Can I simplify this? Can I reduce this? The answer to that simply is yes, you can. You can even, if you want, take an x to the 4, x squared plus 4 to the 2/3 out of everything and get rid of your denominator. You can raise it to certain powers and get rid of stuff. But in this case, I just want you to set up the problem so I understand that you understand the concept. Okay, as I said before, we could spend hours going over how to do algebra again, but in the end, it's just the concept that you're trying to learn. So go to problem 32. This is like the halfway mark only. All right, problem 32. F is x. F prime is 1. G, x squared plus 1 to the 1/2, because it's a fraction. G prime, chain rule. U, inside, x squared plus 1. F of u to the 1/2. U prime, 2x. F prime u, 1/2 u to the negative 1/2. Alright? U prime times f prime u. Half of 2x is just x, so it's x u to the negative 1/2. X times x squared plus 1 to the negative 1/2, which is my g. F prime g. 1 times x squared plus 1 to the 1/2 minus, make sure it's a minus, x squared plus 1 to the negative 1/2 times x. All over x squared plus 1 to the 1/2 squared. Don't forget to square that either. Now, this stays the same. X times x is x squared, and when you do 1/2 and you square it, you get 1. So it's simply x squared plus 1 to the 1/2 minus x squared plus 1 to the negative 1/2, all over x plus 1. All right? Good. If, like I said before, if you want to rewrite it fancier, if I want to divide both of these things by x squared plus 1, this would just be 1/2 minus 1, negative 1/2 minus 1. You don't have to do it this way, I'm just showing you. X squared plus 1 to the negative 1/2 minus x squared plus 1 to the negative 3/2. Okay? These are the same problem. One's written without the fraction. All right? Good? All right. Switch things up even more. Now we're going to simplify the derivative of a power. This is like going inside out. So what do you have to do here? What do you think? What rule do you start with? What am I doing here? You actually start with the chain rule. All right? 3x minus 1 over x squared plus 3 is your inside, right? And what's my f of u? U to the second power. So I have to use the chain rule, not to find f of u, but to find u prime. To find the derivative of the inside, I need this chain rule. So what's my f here? I'm not the chain rule, I need the quotient rule. My f is my numerator, which is 3x minus 1. All right, derivative of that is 3. My g is my denominator, x squared plus 3. Derivative of that is 2x. I have to use now the quotient rule to find u prime. 3 times x squared plus 3 minus 2x times 3x minus 1 all over x squared plus 3 squared. Now I can simplify this. This is an easy one. 3x squared plus 9 minus 6x squared plus 2x. All right, I just left the minus there and did pluses. 3x squared minus 6x is negative 3x squared, right? Plus 2x plus 9 over 3x squared plus 3 squared. All right? F prime u is 2u. All right, so I used the chain rule, and I'm using my chain rule, but I got stuck in my chain rule, so I have to use the quotient rule to find the other part. F prime u times u prime. 2u times all this stuff. All right? 2, my u is this, 3x minus 1, x squared plus 3, right? Times u prime. Now, I'm going to do one simple solution. What is the easiest thing here to do? I'm not even going to distribute that 2. I'm going to leave the 2, 3x minus 1 minus 3x squared plus 2x plus 9 all in the numerator. But look at x squared plus 3, x squared plus 3 squared. 1 plus 2 is, I can just raise it to the third power. All right? Yes, you can multiply everything through the top and simplify it that way, but foils upon foils aren't the most necessary things to do. Okay, it's better off just combining the denominators. That wasn't too terrible, was it? Hope you said no because you're doing another one right now. Go. Ready? Oh, we're at our halfway mark of the lesson, and we're only at an hour. It's a 2-hour lesson. Oh, I'm gonna run out of steam soon. All right, so u is the inside, t squared, t cubed plus 2. F of u, u squared. U prime, I need to use quotient rule, like my magic. F is the numerator, t squared. Derivative of that is 2t. G, denominator, t cubed plus 2. Derivative of that, 3t squared plus 0. 2t, t cubed plus 2, minus 3t squared times t squared. 2t to the 4th plus 4t minus 3t to the 4th. 2t to the 4th minus 3t to the 4th is negative t to the 4th plus 4t over this stuff, and push that over to u prime. Derivative of u squared is 2u. Multiply f prime u times u prime. 2u times this stuff. Plug my u back in. 2 times t squared divided by t cubed plus 2 times this. Remember what I said before? 2 t squared and this stuff. 1 plus 2 is 3. There you go. Why did I say 2 times t squared? Well, instead of just putting the times, I just put them next to each other. Same thing. 2 times t squared times negative t to the 4th plus 4t all over t cubed plus 2 all to the 3rd power. See, this isn't too bad, right? All right, 35. Figure out which method you have to use. That's the tough part now. Should use the quotient to start with. Okay, now we can use like 4 different methods on these. F is my x, because we're not raising the whole thing to a power. That's when you go the other way. Derivative of x is 1. G, the numerator, the denominator is x to the 4th plus 4 to the 1/2. In order to find the g prime here, use the chain. U is the inside, x to the fourth plus 4. To the 1/2 power. 4x to the third, 1/2 u to the negative 1/2. Multiply 1/2 u to the negative 1/2 times 4x cubed. Half of 4x cubed is 2x cubed u to the negative 1/2. All right, 2x cubed, x to the fourth plus 4 to the negative 1/2, which is my, plug it back into this equation, 1 times x to the fourth plus 4 to the 1/2 minus 2x cubed, x to the fourth plus 4 to the negative 1/2 times x all over x to the fourth plus 4 to the 1/2 squared. Now, 1 times this, that stays the same. Negative 2x cubed times x is negative 2x to the fourth. And when you raise a half to the second power, it just becomes the first power. So x to the fourth plus 4 to the 1/2 minus 2x to the fourth, x to the fourth plus 4 to the 1/2, all over x plus to the fourth plus 4. And as I said before, if you want to divide both of these by the bottom, you can. This becomes a negative 1/2, and this becomes a negative 3/2. Is one answer better than the other? Of course not. It's always good for you guys to choose what you want to choose. All right? Boom! Second homework problem. What do you do here? Going the other way. You start with your chain rule. Your u is the whole inside. 1 minus 2v over 1 plus v. F of u to the third power. U prime, we have to use quotient rule. So, F is the inside. Sorry, F is the numerator. 1 minus 2v. Derivative of that is negative 2. G, denominator, 1 plus v. Derivative of v is 1. All right. Negative 2 times 1 plus v minus 1 times 1 minus 2v, all over 1 plus v squared. Negative 2 minus 2v minus 1 plus 2v. Negative 1 minus 1 is negative 3. Negative 2v plus 2v is 0. So you got negative 3 over 1 plus 2v. Negative 3 over 1 plus v squared. Too many v's. Too many letters. Derivative of 3u to the third power, 3u squared. U prime times f prime u. Right? 3u squared times all that stuff. Our u, 1 minus 2v over 1 plus v, and you're going to square it. Ready? 3 times negative 3 is negative 9. 1 minus 2v squared, because you can square the numerator and denominator, and 1 plus v squared times 1 plus v squared is 1 plus v to the fourth power. All right? If you kind of left it like this, it'd be all right. Maybe put like a negative 9 there and just left these two, but look at that. Isn't that so much nicer? Now you can't distribute the 9 in because you're raising that to a power. All right? Problem. Do now. Do it on canvas. Ooh. All right. Inside out. We have to use the chain rule first. U is the inside quotient, x plus 5x squared plus 2. F of u is that stuff to the second power. We're going to need to use the quotient rule to find u prime. F is the numerator, x plus 5. F prime is the denominator, x squared plus 2. Oh, sorry. Derivative of x plus 5 is 1. G, x squared plus 2. G prime, 2x plus 0. F prime G, 1 times x squared plus 2 times 2x times x plus 5 all over x squared plus 2 squared. X squared plus 2 minus 2x squared minus 10x. Combine like terms, that becomes a negative x squared minus 10x plus 2 all over x squared plus 2 squared. F of u, 2u. All right. Multiply the two of them together. 2u times u prime, 2x plus 5 over x squared plus 2. That stuff. As I said before, 2 times x plus 5 times negative x squared minus 10x plus 2 all over x squared plus 2 to the 1 plus 2 is third power. All right. All right. Repeat applications of the chain rule. What does that mean, repeat applications? You have a clue? What that means is you have a chain rule and you have another chain rule. So you have a double chain rule. So, first off, work from the outside in. It's all this stuff to the second power. You like my box? So my u is the whole entire inside. It's x squared plus 3 to the fifth power plus x. All right? And what am I raising that to? I'm raising it to the second power. All right, not too terrible yet, right? Now, in order to derive this, I'm going to need another chain rule. Why? Because I don't know what x squared plus 3 to the fifth power is without using the chain rule. So, these are a separate set of u's and f of u's. So what is my u just for this part right here? X squared plus 3. And I'm raising it to what power? U to the fifth. We're going to deal with this x later. We don't have to deal with it right now, okay? But if this x wasn't here, I could have just raised the fifth power to the second power and made it to the 10th. But because this little bugger is in there, it messes everything up. So, x squared plus 3, 2x. U to the fifth, 5u to the fourth. Follow me still? 2x times 5u to the fourth. 2 times 5 is 10x, u to the fourth power. 10x, you're using this u, because we're still in this problem, x squared plus 3 to the fourth power. Okay? Now, that is the derivative of this, and then we also have to do plus x, what's the derivative of x? Derivative of x is 1. So this is my u prime. All right? Got it? Derivative of u squared, 2u. Now, this times this. 2u times 10x, x squared plus 3 to the fourth power plus 1. So I can do a 2 times 10x times 1 if I want, or just leave the 2 out front. How about I just replace the u? Now when I replace this u, I replace it with my original u. Not this one. This, once I find this stuff down here, all the shaded part is done. So I replace it with my original u. So 2 times x squared plus 3 to the fifth power plus x. 2 times that. Times 10x. X squared plus 3 to the fourth power plus 1. That's it. Pretty easy, right? All right, do problem 38. All right, let's see if you got it. Our original u. Work from the back way. What are you doing? I'm raising everything to the third power. So everything I'm raising to the third power is my u. 2 plus x squared plus 1, all to the fourth power. F of u is u to the third. Or to find u prime. Well, the derivative of 2 is 0, so I don't care about that. Derivative of x squared plus 1 to the fourth power. X squared plus 1 to the fourth is my u. My f of u is this to the fourth power. U prime, 2x, 4u to the third. 2x times 4u to the third. 2x times 4 is 8x u to the third. 8x, this u, to the third. 8x, 1 half x to the squared plus 1 to the third power. And that's actually my u prime, okay? That's plus 0 because the derivative of 2 is 0. F prime u, 3u squared. 3u squared times 8x squared plus 1 to the third power. 3 times 8x is 24x. U to the squared, e to the second power, x squared plus 1 to the third power. Take my original u and plug it back in. 24x, 2 plus x squared plus 1 to the fourth power. That whole thing squared, x squared plus 1 to the third. All right. The other one, problem 39. So, you should have the hang of this by now. All right. So, first thing. 6u to the 1/3, right? So 4 plus 3x to the 4th minus 5e to the x all to the 7th is my u, and my f of u is 6 cubed root of that, so 6u to the 1/3. Need the chain rule for that. So, u, 3x to the 4th minus 5e to the x. F of u is u to the 7th power. U prime is 12x to the 3rd minus 5e to the x, because remember the derivative of e to the x is e to the x. 7u to the 6th. All right? Multiply these guys by each other. 7u to the 6th times 12x cubed minus 5e to the x. Gives me 7 times 3x to the 4th minus 5e to the x, all to the 6th power, times 12x cubed minus 5e to the x. And then that is plus 0. So I'm just going to leave my u prime like that. Okay, can you distribute the 7 to these? Of course you can. Calm down. You don't need to worry about that. Derivative 6u to the positive 1/3. 1/3 of 6 is 2. U to the negative 2/3. Now we multiply these guys together. What we can do is 2 times 7. We can multiply those two. 14. 14, the original u, 4, 3x to the 4th minus 5e to the x, all to the 7th, to the negative 2/3, times this stuff, times that stuff. Looks a lot worse than it really is. See, look, if you could just figure out, if you would have thought to yourself, wow, a couple months ago, I'm going to be able to get an answer that looks like that, and I'm going to do it fairly easily. You're pretty proud of yourself, aren't you? You should be. Do what? All right, we're going to take a little break from this stuff because it's getting a little tricky for you, right? Ready to go a little easier and then go tougher in a little bit? I know you're saying I've been doing this over an hour. What do you mean a little bit? But this is a long lesson. Well, it takes a lot of days. Trig functions and the chain rule. So first thing, how does the trig functions work with the chain rule? Derivative of sine u is cosine u times u prime. Derivative of cosine u is sine u, negative sine u times u prime. Secant squared u times u prime. Negative cosecant cotangent times u prime. Secant tangent times u prime. Negative cosecant squared u times u prime. So it's the same concept as before. The only difference is when you find it, you take whatever is inside the trig function that stays there, and you multiply it by the derivative of that thing that's inside the trig function. Like, what? What is he talking about? I'll show you. Derivative of y equals sine 2x. Now let's look at this. What is my u? It's what's inside the trig function. It's 2x. I gave you the hint. What's my f of u? Sine, replace that with the u. Derivative of 2x is 2. Derivative of sine u is, derivative of sine is cosine. So, using this, it would just be cosine u times u prime, which is 2. So it'd be 2 cosine u, and what was my u? 2x. 2 cosine 2x. So what you're doing is, derivative of 2x is 2, cosine 2x. You can write it out if you need to. U, what's your u? X minus 1. F of u is cosine u. Derivative of this is 1. Negative sine u. Negative sine u times 1 is just negative sine u. Negative sine x minus 1. Trig functions are easy. Right? 42 tan 3x. Your u is 3x. F of u is tan u. U prime. Anything? 3. F prime u, secant squared u. So it'd just be 3 times secant squared u. 3 times secant squared, 3x. Notice this stays the same inside the trig functions, okay? Here's some tricks. There's always tricks involved. Try these problems, see what you get. First one. We're not even going to go solve these. We're just going to find the tricks. What is my u here? 3x. What's my f of u? Cosine u. So that's the basic one, right? 44. 44 gets about, I'd say 85% of students get it wrong. Are you one of those students? What's my u? Well, cosine 3 is a constant. It actually equals 0.9. So the answer here is 0.9x squared. So what's my u? There is no u. There is no f of u. The answer to this would just be 1.8x. See? Told you. If there's no variable inside the constant, inside the trig function, sorry. If there's no constant inside the trig function, you don't need to use these rules. All right, problem 45. Well, you have to, 3x squared is my u, right? What does 3x squared equal? Not 3x squared, it actually equals 9x squared. This problem right here is cosine 9x. So 9x squared is my u. My f of u is cosine u. That was easy. What about 46? This one gets some people too. Well, this is the same as cosine x squared. So my cosine x is actually my u, and my f of u is u squared. That's the same as cosine x to the 1/2. Your cosine x, once again, is your u. And u to the 1/2 is my f of u. Alright? So you just got to be careful when you're doing this, okay? Got it? So those are some tricks you may run into. Find the equation of a tangent line of the graph of tangent line, the same as derivative. Derive this. Go. All right. First one's easy. What's the derivative of 2 sine x? So you derive each function independently. You should know that. 2 cosine x. That's an easy one. Derivative of cosine 3x. This one, you need to use your chain rule. What's my u? 3x. F of u. Cosine. Derivative of that is 3. Derivative of cosine u is negative sine u. So, negative sine u times 3 is negative 3 sine u, or negative 3 sine 3x. And guess what? Boom. Add them together. That's your answer. 2 cosine x minus 3 sine 3x. See? Told you could do it. All right. Cosine 4x. What do you got? Anything good? What's u? 4x. F of u is cosine u. 4, negative sine u. Negative 4 times sine u, so the answer is negative 4 sine 4x. Once again, derivative of 4x is 4. Derivative of cosine is negative sine, and you keep the inside function. All right. Now you're like, this is easy. Problem 50. Pi is actually a constant. So your u is pi x, your f of u is sine u. Your u prime is pi times the derivative of x is 1, so it's just pi. And then your f of u is cosine u. So you got cosine u times pi, or pi cosine u, pi cosine pi x. Do some more. These are a lot better than like triple derivatives, aren't they? Double derivatives. And no, you don't have to do a triple derivative of a chain. All right, let's look at this one. Your u is 3x again. F of u is 5 tan u. U prime is 3. And the derivative of that is 5 secant squared u. 3 times 5 is 15 secant squared u. 15 secant squared. Put back in 3x. 52. A little tricky here. Secant of x squared. Or is it tricky? It's not secant squared x, it's secant x squared. So in this case, actually, your u is your x squared. F of u is secant u. And then you get 2x and secant u tan u as your derivative. So this is a little tricky. There's 2u. So you have 2x, secant u tan u. So which one do I plug in the x squared to? What do you think? Correct, both of them. 2x times secant x squared tan x squared. All right. 53, 54. Ready to up it a level? Boom. Whoa, what do you do here? What special rule do you think you have to use for problem 53? Same one, 54. Into the P. Ends with an adduct. Product rule. What is my F? My F is sine 2x. What's my J? Cosine 2x. Oh. Now, let's see if you remember the trick. So the trick is you take the derivative of 2x. Derivative of 2x is 2, right? Derivative of sine is cosine. So it's 2 cosine 2x. See? You don't even need to write out your u's and f of the u's. Cosine 2x. Derivative of 2x is 2, so 2 goes in the front. Derivative of cosine is negative sine. Negative 2 sine 2x. F g prime. Sine 2x times negative 2 sine 2x plus cosine 2x times 2 cosine 2x. Plus with the product rule. Now, watch what happens here. Negative 2 comes forward. What's sine 2x times sine 2x? The whole thing squared. Or, how can we write this better? Cosine 2x is cosine 2x squared. This looks a little yucky. I sound like I'm talking to my 3rd grade daughter. Yucky. The 2 can go right in front of the sine. The 2 goes right in front of the cosine. And then it's nice and cleaned up. Negative 2 sine squared 2x plus 2 cosine squared 2x. Says the same thing. All right. So do problem 54. Got it? Your F, secant 1/2 theta. Derivative of 1/2 theta is 1/2. So it's 1/2. Derivative of secant is secant tan. 1/2 secant 1/2 theta, tan 1/2 theta. Your G is tangent 1/2 theta. Derivative of this is 1/2. Derivative of tangent is secant squared 1/2 theta. One half first, secant 1/2, secant squared 1/2. That means there's 3 of them there. You got 1/2 dragged to the front. Tan, and a tan is a tan squared, secant. Secant cubed, 1/2 theta, plus 1/2 tan squared, because of the 2 tans. 1/2 theta, secant 1/2 theta. Isn't it fun writing trig stuff? Not that much work, it just gets confusing with all the letters and the numbers and all that other fun stuff mixed up. All right, let's go pop off a do now problem real quick. Do these 2 do nows, and it looks like you may have to use something called a quotient rule. Just making sure I'm still videotaping here. All right. Problem letter A. My F, my numerator, cotangent x. F prime, negative cosecant squared x. J, sine 3x. Let's see if you remember G prime. 3 cosine 3x. Plug them in. Negative cosecant squared, sine 3x. 3 cosine 3x times cotangent x. There's a minus here, and you're squaring your G. All right, so let's look at this. Can we simplify this at all? This stays the same. Minus stays the same. And we just take the square and put it right here. All right. Pretty easy. Cosine 2x. 2 negative sine 2x, or negative 2 sine 2x. Cosecant x, or negative cosecant cotangent x. Multiply the 2. Negative 2 sine 2x times cosecant x Nothing combined here. Minus cosine 2x, negative cosecant x, cotangent x, nothing combined here. All over cosecant x squared. There you go. Cosecant is 1 over sine, so technically cosine over sine. If you want to get like fancy, you could say it's cotangent, but this is a 2x, so it doesn't matter. All right, you got some stuff working some weird stuff over here. You could also, if you want, take a cosecant out of here, here, and here. You need one cosecant on bottom. All right, a lot of ways to take care of that problem to reduce, but not that important. Repeated trig functions using the chain rule. So this is using like a double chain rule with trig functions. So the first thing you want to do is you want to rewrite this. Sine 4t all to the third power. Now, here's your first one. We're raising this whole thing to the third power. So when you're doing this, my sine 4t is going to be my u. My f of u is going to be this to the third power. Now, you don't have to make this big chart because we know how to do this in our head, but I'm just showing you how you're using it repeatedly. So now we're going to have to derive sine 4t. We can use the chain rule again, and our u is 4t, our f of u is sine u, 4 and cosine u. So this would be 4 cosine u, or 4 cosine 4t. Now, as we did before, and this is 3u squared. You can 100% do this in your head. This is stuff you could do in your head. I go derivative of sine of 4t is 4, so 4, derivative of sine is cosine, and keep my 4t. You don't have to write this out. You shouldn't have to write it all out. But a lot of students were like, where did that come from? So I wrote it out. Anyway, u prime times f prime u, we're done already. 3u squared times 4 cosine 4t. 3 times 4, 12u squared cosine 4t. 12, our original u, sine 4t, squared cosine 4t. And then just take that squared and put it next to the letter that says sine. So it's 12 sine squared 4t cosine 4t. And we're done. Not with the lesson, just that problem. We're almost done with the lesson. Let's do some more trig. Yay! All right. Good. All right. Let's see. You can actually square the pi, which is a constant, square the x. So now you only have to do this once. Pi squared is like somewhere around 10. And then you got x squared. So our u is pi squared x squared. Our f of u is sine u. Oh, I went u prime. U prime is 2 pi squared x. All right. Sine u, cosine u. 2 pi squared x times cosine u. All right. 2 pi squared x times cosine pi squared x squared. That's a crazy looking problem, isn't it? Or if you want to make it go back like this, 2 pi squared x times cosine pi x squared. These are the same. You can. Either way is okay. Good? All right. Problem 58. Y equals cosine 1 minus 2x quantity squared. This is a double chain. What's my original u? 1 minus 2x squared. F of u is cosine u. All right, in order to find the derivative of this, I have to use the chain rule again. U is 1 minus 2x. F of u is u squared. This becomes negative 2, and this becomes 2u. All right, follow me still? Negative 2 times 2u is negative 4u, or negative 4 times 1 minus 2x. I can distribute this in, negative 4 plus 8x, or 8x minus 4. Derivative of cosine u is negative sine u. Now we're set. Negative sine u times negative 4 plus 8x. Just distribute the negative. You got 4 minus 8x, or negative 8x plus 4. Like I said earlier this lesson, I like to put my x's before my constants. Sine u. Take my original u, 1 minus 2 all squared, and plug it back in for sine. This 2 does not move here because I'm not squaring the whole equation. I'm just squaring the part that's inside the equation. So this is your final answer. negative 8x plus 4 times sine 1 minus 2x quantity squared. All right. Awesome. Hopefully you're nice and fresh. You took breaks between this whole lesson. You didn't do it straight through. 59. Let's look. That's the same as 4 secant 7x quantity squared. So, my first u, 4u squared. So, secant 7x is my u, I could see. All right, f of u, 4u squared. I went out of order. So, the derivative of this would be 7, and the derivative of secant is secant tan. So, it's 7 secant 7x tan 7x. 7, 7, 7. Lucky. F of u is 4u squared, 8u. Multiply these by each other. 8 times 7 is 56u. Secant 7x, secant 7x, tan 7x. The u is secant 7x, so all I did was I plugged it back in. Secant 7x is 2 of them, so 56 secant squared, 7x, tan 7x. All those secants and tans like make your brain explode. It's okay. I feel you. I feel the same way. All right, problem 60. Five, since this is squared, is 5 times cosine pi t quantity squared. Our cosine pi t is our u. Derivative of this is just pi times negative sine pi t, or negative pi sine pi t. So this was actually chain rule. We're using a chain rule to get this, but you're doing it in your head now because you're so good at this. F of u is 5u squared, 10u. 10u times negative pi sine pi t, negative 10 pi u sine pi t, negative 10 pi cosine pi t sine pi t. All right, these were your homework problems. Ready? Rewrite this. Since the square root is here, we're squaring the whole entire thing, so it's tan 5 theta t squared, not t. That's our u, as you can see, and our f of u. So tan 5 theta is our u. Derivative of tan is secant squared, so this becomes 5. Secant squared 5 theta. F of u is u squared. Derivative of that is 2u. 2u times 5 secant squared 5 theta. 2u times 5 is 10u secant squared 5 theta. 10 tan 5 theta secant squared 5 theta. Okay. 4 cosine 8 theta to the 1/2 power. Cosine 8 theta is your u. Derivative of this is 8 times negative sine 8 pi, so negative 8 sine 8 pi. 4u to the 1/2. 1/2 of 4 is 2u to the negative 1/2. 2u to the negative half times negative 8. 2 times negative 8 right here is negative 16, u to the negative 1/2 sine 8 pi. Negative 16 cosine 8 pi to the negative 1/2 sine 8 pi. Not 8 pi. Negative 16 cosine to the negative 1/2. 8 theta sine 8 theta. All right. All right. Ready to do fun ones? Second derivative. So we're going to go back. A second derivative. These aren't too bad. If they were bad, I wouldn't be able to fit 2 on a page. So use the chain rule to find the second derivative of these two functions. Ah, you didn't think I was going to do that, did you? So do it the normal way. U, 2 minus 7x, f of u, 5u to the 4th. Good. Negative 7, 20u to the 3rd. Negative 140, u to the 3rd power. When I multiply. Negative 140, 2 minus 7x to the 3rd power. That's 1. find the second derivative, we have to derive this one. Just use the chain rule again. I had to think myself. Like a robot. I'm starting to freeze right now. 2 minus 7x is again my u. My f of u this time is negative 140 u to the third power. This is still negative 7. 3 times 140 is negative 420 u squared. Multiply these two. Negative 420 u squared times negative 7. Negative times a negative is a positive 2,940 u squared. Plug back in my u. 2,940, 2 minus 7x quantity squared. All right, see, it wasn't that bad, was it? You're just doing a chain rule and then a second one. So do the next problem. Good, we'll probably end this at about an hour 40. It's not terrible, like the last one. X squared minus 2. 4u cubed. 2x. 3 times 4 is 12u squared. All right, 2x times 12u squared is 24xu squared, right? 24x, x squared minus 2 squared. Still okay? Uh-oh. Sorry. Looks like a product rule for me. Hopefully you used the product rule, did you? I was wondering why I started to squish things in here. So your f is your 24x. Actually, I'm not sorry. This is easy. Your g is your x squared minus 2 squared. But in f prime, 24. G, and there's a chain rule inside the product rule. Why would he do this to us? I told you there's two of them. U, x squared minus 2. U squared. 2x, 2u. 2x times 2u is 4xu. 4x, x squared minus 2. Is that really that bad? 24x times 4x. Sweet. 24x times 4x cubed minus 8x. I just distributed this in there. That's where this and this are the same. Plus x squared minus 2 squared times 24. Right? Final answer. 96x to the fourth minus 192x squared plus, just move the 24 forward, times x squared minus 2 squared. I'm not going to FOIL that. I'm just going to leave it. Boom! Nice and easy. Could you have left it like this? Of course you can. It's fun to go more math, isn't it? All right, now we're going to go even further. Why don't you guys find the second derivatives of these two problems? Ooh, it's quotient rules. We hate quotient rule, right? You don't need to use the quotient rule here. Watch this. X minus 6 to the negative 1/2. So u is x minus 6. F of u is u to the negative 1. Watch how much easier chain rule is. 1, negative 1 u to the negative 2. 1 times negative 1 u to the negative 2, right? Is just negative u to the negative 2. Negative x minus 6 to the negative 2. Derivative 1. Derivative 2. U inside x minus 6. F of u, negative u to the negative 2. 1, 2, u to the negative 3. 2u to the negative 3 times 1 is just 2u to the negative 3. Or 2x minus 6 to the negative 3. Or 2 over x minus 6 cubed. See that? It's actually not that bad to do. Told you. So you don't get mad. It's scary when you see stuff like this. 66. Got it? U. X plus 2. Because this is the same as 4, x plus 2 to the negative 3. So x plus 2 is your u. This is 4u to the negative 3. 1. 4 times negative 3 is negative 12u to the negative 4th. All right? 1 times that is itself. It's still negative 12u to the negative 4th. Negative 12. X plus 2 to the negative 4th. First derivative. All right? Second derivative. U. X plus 2 to the negative, x plus 2. F of u, negative 12, u to the negative 4th. 1, negative 48u to the negative 5th. Good. Negative 48u to the negative 5th times 1 is just negative 48u to the negative 5th. Or 48 x plus 2 to the negative 5th. Or 48 x plus 2 to the 5th. All right. Seems pretty easy to me, doesn't it? Ready for a hard one? There's only a couple problems left, so now we're going to get to the really tough one. These are ones I typically don't even cover in class because we're running out of time. Find the second derivative of the function. So now we got a trig function. Anytime you see this, be scared. All right, so first one. Easy. What's our u? Our inside is x squared. F of u is sine u. U prime. 2x cosine u. Okay? Cosine u times 2x is 2x cosine u, or 2x cosine x squared. You could have done this in your head. 2x cosine x squared. All right? Second derivative. What do you have to do here? Product rule. F is 2x, g is cosine x squared. F prime is 2. I can tell you right now the answer to this is negative 2x sine x squared. Because if you derive this and put that back in, you're good. If you're, about half of you guys can probably do it like this, but I'm going to write out a work. U, x squared, f of u, cos u. 2x, negative sine u. Negative sine u times 2x, or negative 2x sine x squared. All right? See? Right in my head. F g prime. Oh, I got my colors all mixed up. Whatever. 2x times negative 2x sine x squared times 2 times cosine x squared. 2x is negative 4x squared. Sine x squared plus 2 cosine x squared. All right? Ready for the do now? Problem 68. Find the second derivative. Should be done on campus. All right, so that's secant pi x quantity squared, right? So u, f of u prime, f prime u, all this fun stuff. U is the inside, secant pi x squared. Derivative of secant pi x. Well, derivative of pi x is just pi, so it's pi, and then you got u squared. So it's pi secant pi x tan pi x. Whatever that is, 2u. I didn't write it out because I don't have enough space, honestly. All right, so this one right here. This times 2u. So pretty much just 2 pi 2 times secant pi x times pi secant pi x times tan pi x. Or you have a secant pi x, a secant pi x. The 2 and the pi combined. So it's 2 secant squared, 2 pi secant squared, pi x tan pi x. Right? Second derivative now. Now we're going to have some fun. What in the world is going on here? I'll show you. Your f is 2 pi secant squared pi x. All right? Your g, tan pi x. This is the same as 2 pi secant pi x squared. So I'm going to have to use a chain rule inside here. Now watch. And you're actually using chain rules all over. You're using like 5 chain rules in this problem. U is secant pi x. And we know that the derivative of f of u is 2 pi u squared. Okay? We already found the derivative of secant pi x using the chain rule over here. We got pi secant pi x times tan pi x, right? Good. Derivative of this is 2 times 2 is 4 pi u. Multiply these by each other. 4 pi u times pi secant pi x tan pi x is 4 pi, we put this back in, secant pi x times tan x. So 4 pi times pi is 4 pi squared, secant squared pi x tan pi x. Might have to do a lot of pausing and rewinding here. This one I used to just took too long, so this was like a bonus one for all my students. Derivative of tan pi x. Derivative of pi x is pi. Derivative of tan is secant squared, so it's pi secant squared pi x. This is the product rule, FG prime. This 2 pi secant pi x times pi secant squared pi x, that's on this side, and this one is 4 pi squared secant squared pi x tan x times tan pi x. I missed a tan pi x? I missed one. There should be another tan pi x down here. Oh no, there it is. When it gets too many letters, my head goes spinning. So these things become tan squared pi x. All right. And these become secant 2 plus 2 is 4. These become 2 pi squared. So you got 4 pi squared secant squared pi x, tan squared pi x plus 2 pi squared secant to the 4th pi x. Aha! Got it. Fun one? You know it's fun. That's a great one. All right, ready for the next one? This one's not as fun. It's too easy. Actually, it is just as fun. Anytime you have fractions over fractions inside functions. You start with the chain rule. Your 3x squared over 1/2 x minus 7 is your u. Your f of u is u squared. How do we solve this? Oh, this is an easy one. Anyway? Quotient rule. F. 3x squared. G. 1/2 x minus 7. So derivative of this is 6x. Derivative of this is 1/2. Okay? 6x times this minus 1/2 times that over this squared. Half of 6 is 3x squared minus 42x minus 3/2 x squared over this squared. 3x squared minus 3/2 x squared is just a positive 3/2 x squared minus 42x over this. And take this, push it over there. Derivative of u squared is 2u. Try to see how crazy of a problem we can get. All right, multiply these by each other. This is actually pretty good. When you do this, you can distribute the 2 to the tops. Oh, I didn't even do that. I just plug my u in. All right. This and this become to the 3rd power. All right. If I do, ready? You want to know where this comes from? 2 times 3x squared is 6x squared. 6x squared times 3/2 x squared is 9x to the 4th. 6x squared times negative 42x is negative 252x cubed. So if I multiply all 3 of these tops by each other, I get this stuff. And then I multiply these, I get this. All right? It just cleans it up a little bit. These are all extra problems, so you didn't have to go that far. But it's always good to be very strong in algebra. You're going to need it forever. All right. Problem 69. Oh, it's the last problem. We made it. Under 2 hours. I'm very proud. All right. Do we use the division rule? Let's see. This is the same as, watch this. I gave you an easy, actually, I gave you a frustrating problem. Square root of 1 over the square root of x squared minus 2. Okay? We're going to save you some chains here. Square root of 1 is 1. over the square root of x squared minus 2. This is the same as 1 over x squared minus 2 to the 1/2, or x squared minus 2 to the negative 1/2. So do we even have to use the quotient rule? No, we don't have to use it. You're welcome. All right, so look, you can always sometimes simplify things to make it a lot easier. You could have used the chain with the quotient within the chain, but if you just simplify the equation, watch this. X squared minus 2, u to the negative 1/2, 2x, negative 1/2 u to the negative 3/2, multiply them together. Negative 1/2 times 2x is negative x, u to the negative 3/2, negative x squared minus 2 to the negative 3/2. And look at that. Done. See how easy that was? By getting some work done in the beginning, it saves us a lot of time in the end. Will the other way work and give you the proper answer? Yes. This answer is actually, what is it? Negative x over the square root of x squared minus 2 to the 3rd power. That, you get something like that. We don't need to. All right. These, when you take your test, you'll be given all this fun stuff. We didn't really go over these. These are ones that did in the past. Those will happen later on in the year. But your trig functions, the little shortcuts here that we've been using. All right. Chain rule, quotient rule, product rule. Should know all these by heart. But you might not. But now, anyway, it was on page 36. You should be done with the chain rule. You guys are experts now. You should have this whole thing done with. You should know how to use the chain rule. Use the power rule if you want to. Not that big. Find derivatives of functions, second derivative of functions, derivative of all types of trig functions now. So very, very important in math. Okay, so this pretty much concludes all the basic parts of all the types of derivatives you need to know about. The only thing added onto this is implicit differentiation, which is when you differentiate both sides of the equation in respects to different variables at the same time. But as far as basic, regular, straight up single variable differentiation, you're experts now, or you should be. Next thing we'll do is review, take a test. All right, so till next time. I know it was a little long, but it wasn't too terrible. Good luck on when you take the test then. See you next time.